All right. It says, how many 4-digit PIN codes use numbers and have no repeated digits? So we need 4 numbers. 1, 2, 3, 4. My digits cannot repeat. So I start with a 10. We've got 10 digits. Then I've got 9 digits, 8 digits, 7 digits. Instead of writing it out like this, I can put 10 permutate 4. That's your shortcut.
Couldn't you have done, couldn't you also do the 10 exclamation point?
No, because then that would do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If you went clear down to 1, if you had to go clear down to 1, then yes. Okay, so what this tells you, and there's actually a button on your calculator that I will show you in a little bit. This tells me that I start at 10, and I multiply the next 4 numbers. 10, 9, 8, 7. It's called a permutation. Okay, in a permutation, the order matters, and you cannot repeat. Okay, order matters, and you cannot repeat. Number 2, a 5-character password is not case sensitive. How many passwords use only letters and do not reuse any letters? So what does that look like when we did it?
26, 25.
26, 25, 24, 23, 22. As a permutation, we can write this as 26, that's the number I started at, permutate, how many slots did I fill in? 5. So I would accept this as an answer or this as an answer. I don't care if you use permutations or combinations, but you need to be able to mathematically either do it this way or give it to me this way. I don't care which. Both of them will give you the same answer. Okay? Number 3, 7 people are standing in line at the DMV. How many different ways could these people arrive at the DMV? How do I know that this is a permutation? What tells me that the order matters and can't repeat?
They're in line.
They're in line, but we're also talking about people. Okay, when you're talking about people and people have to be in certain positions, it is a permutation. If it just said 7 people in a room, that would not be a permutation. But because you're putting them in an order, in a line, that's what makes it a permutation. So what do I start at here? 7. How far do I go down if I'm lining up everybody? We go clear down to 1. I want everybody in line. 6, 5, 4, 3, 2, and 1. This is 7. Permutate 7 or 7 factorial. So when you started a number and you use all the numbers clear down to 1, these 2 numbers should match from my permutation, or you can write it as 7 factorial. The 7 factorial goes the whole way down to 1. Does that make more sense? Why you couldn't use it on the last one? Okay. All right. How many different ways can 8 racers finish first, second, and third? What does that look like? 876. Again, this is permutation because we're looking at specific places. They're landing in first place. They're landing in second place. They're landing in third place. I could also write this as 8 permutate 3.
So the remaining numbers don't matter.
No, because you're only looking at 3 specific places. Now, if it said finish first, second, third, fourth, and fifth, that would be 8, permutate 5. You want 5 places. So this basically tells you I start at this number and I need 3 numbers altogether. Okay. All right, so this is what we call a permutation. Permutate or permute means to order. That's why I never understood why they called combination locks. Because there should technically be called a permutation lock. Because the order matters. If you switch up the combination, it's not going to work. It's not a combination, it's a permutation. I giggle about it. So, some things you're looking for is order of your object matters. So, if we're talking about different places, or characters in a password, or number, or line, or arrangement, that tells me permutation. Okay? If we're talking about different jobs, or duties, or positions. So, when we did the president, vice president, treasurer, those are 3 different positions. If I just said 7 people are running for student council, those aren't positions. Everybody has the same spot in student council. Okay? You have to be specific for a permutation. Objects cannot be reused in the arrangement. No replacement or repetition. So, permutations isn't ordered. That's our big word for this section. Ordered. Your notation then is NPR. N is the total objects. R is the number of ways to order them. So how many do I need? Do I need 4 of them? Do I need all of them? Do I only need 2 of them? What do I need? I'm not showing you how to do it longhand. It's not happening. So you can ignore that part. It's done. Because you ain't going to do it.
You're right.
Okay. So you're going to have a section on your test. I want you to be able to decipher what this means. Okay. So not technically the long way. Okay. So if I have 6 permutate 2, what number do I start at?
6 and then 5.
6 times 5. I need 2 slots. That's what I want to see on your test when I give you something like this. 6 times 5. Okay, so here.
Just 100? Oh, okay.
Sorry, down here. B. 6 permutate 4. So where do I start? 6,
4,
5, 4, 3. I need 4 numbers. Is it clicking?
Right.
Whoop, there it is.
Oh, that's easier.
10 permutate 1. Or yeah, 10. 100 permutate 1.
100.
100. It's just 100. You only need 1 number. You're done.
I now I'm getting smart again.
Getting smart again?
Yeah.
10 permutate 9. Where do I stop? What number do I stop at?
2.
2. 10, 9, 8, 7, 6, 5, 4, 3, and 2. I need 9 numbers. Happy New Year. E, 4 permutate 4.
3, 2, 1.
I need 4, 3, 2, and 1. And 13 permutate 5.
3, 13,
12, 11, 10, and 9.
12, 11, 10, and 9.
Wait, did we just think? Oh, we did.
We did all of them.
Okay. Not too bad, right?
I like that part.
Say.
Yeah.
Say, my playmate. Come out and play with me.
Okay, that part was
And
easy.
bring your doggy free.
I don't know that.
I'm just showing my age. Y'all never sat like in front of each other and did say my playmate.
We did patty cake, I believe.
Oh,
I did
patty
all
cake,
of them,
Johnson?
can't you
Apples
see?
on the stick. Make things make my heart go. You don't know
know.
Wow.
Okay. So, not all of these are going to be permutations. You need to figure out how we handle it. Remember, permutation means no repetition and order matters. So, it says consider the letters A, B, C, D, E, F, G, H. How many 4-letter words can be made? We're not looking for actual 4-letter words. We're looking for like A, B, C, D could be a word. Okay. It's not an actual word, so be careful with that. Okay. So A says letters can be reused. Is that a permutation?
No.
No, it says I can reuse. So I've got a 4-letter word where my letters can be reused. How many choices do I have? 8. 8, 8, 8, and 8. Or you could write that as 8 to the 4.
Hey, Ashley, do you know what we're doing today in AC? No, don't worry. Are we telling her our abstract or showing?
Okay? B. Letters cannot be repeated. What does that look like if my letters cannot be repeated? 8, 7, 6, 5.
If you would stop talking, I would be able to hear.
8P4.
But I'm hearing you gossip in the back.
Shut up. I am teaching. You should be paying attention. Shush.
Yes, show how to.
She doesn't do it in any class.
How would you know? My grades are.
Okay. C. No repetition, and D has to be the last letter. No repetition, and D has to be your last letter.
7, 6, 5, 4.
I agree with 7, 6, 5.
1.
This is a 1.
My bad.
Okay, that has to be a D. You only have one D. Okay, because that last one is a D, that means D can't be in any of the other slots, which is why we start with a 7. 7, 6, 5, and then the 1. You can also write this as 7 permutate 3 times 1. Okay, I don't care. Either way.
What are you throwing at me? My leg.
Okay, look at this one. 7 candidates are planning to interview for a job, but there are only 4 interview slots at 1 p.m., 2 p.m., 3 p.m., and 4 p.m. with the company. How many different interview schedules can the company create? What makes this a permutation? The specific times. Because they went specific with the times, if they just said 4 slots, it would not be a permutation. But because they got specific with the times, it is one. Shh. I can't help it, my board's off. Stop talking junk. So, either you can write this as a permutation or write it out. What would this look like written out?
You would write out 4 lines,
4 lines.
and then you would do
4, 3, 2.
7, 6, 5, 4. I have 7 candidates that could go at 1 p.m. Whatever candidate goes there can't go in slot 2. They can't go in slot 3. They can't go in slot 4. So 7, 6, 5, 4 or 7 permutate 4.
Hey, for the number 2, you wrote out 7P3 times 1,
Mhm.
then you put equals.
You would just answer it. That's just the other way to write it. Ignore the equals. Okay. Questions? We're almost done with permutations. Look at that. Jeff has 20 CDs that he regularly listens to. How many ways can Jeff put his CDs into his new stereo? Into his new car stereo system. Why is this a permutation?
It's 1 through 6.
It's labeled 1 through 6. If I put Metallica in slot 1, I can't push slot 4 and listen to Metallica. Listen, I was trying to go with the cool. Y'all listen to Metallica?
Nope.
Oh, God.
We're not that old.
Listen. Okay,
It would be
so what does this look like?
20,
20, 19, 18, 17, 16, 15. Slot 1, slot 2, 3, 4, 5, and 6. Or 20, permutate 6.
Are we gonna have to write it like both ways? Or
No.
just one?
I will take one or the other. Some people stick with the P's, some people stick with writing it out like this, so I'm showing both.
What if we do both?
That's fine too.
No.
I also need to show you where that button is on the calculator so you can find it. Okay. A passcode is 8 characters long. No repeated characters, but the first 5 have to be lowercase letters and the last 3 must be a number. What does this look like?
26 times 26 times 26 times 26 times 26.
No.
Oh, really? No?
I agree with it. Starts at 26.
25, 24.
It says no repeated characters. So 25, 24, 23, 22,
And then
because your first 5 are letters.
10, 9,
10, 9, 8 for my numbers. Okay, so we could write this as 26. Whoops. You could also write this as 26 permutate 5, because I've got 26 letters and I'm filling in 5 slots, times 10 permutate 3. I've got 10 numbers and I'm filling in 3 slots. Four people are running for the position of president, vice president, treasurer, and secretary. How many different ways could these people hold these 4 positions? Again, what makes this a permutation?
the vice, yeah, the
We're talking specific positions: president, vice president, treasurer, secretary. Okay, if it just said they're running for office, that's not a permutation. Okay, so what does this look like?
4P4.
4P4 or 4 times 3 times 2 times 1. Y'all are gonna ace this test on Friday.
Don't jinx
No,
that.
that's us.
Don't jinx us.
No,
I don't know about that. Right.
I'll get at least. Right. I'll take that.
I mean, this is a partner.
I get at least a 16.
Is this like the last one, like partner?
She said did she say it was gonna be a take home?
No, that's the next one.
Kelly was happy.
She don't pay attention. See, I told you she don't pay attention.
I do pay attention.
Listen, I tell you all the time she don't pay
She
attention.
already said this.
She formulates things in her head that she wants to
I
hear.
So back to my
And then roll.
So back to my question.
Oh my God.
Is this gonna be a partner?
I've not decided yet. I'm thinking on it. I'm thinking about it.
What is your options? Well,
Okay, on the first day of class, this is why I taught you the permutation. Because read this one. On the first day of class, 30 students find themselves in a classroom with 30 desks, already arranged for them, but the teacher made no seating chart. The teacher gives the students free seating and will write down the seating chart afterwards. How many different seating charts are possible in this situation?
30P30.
30P30.
Oh,
This is a permutation. Because if Ashley sits in this seat,
then she can't sit.
Kimberly can't sit on her lap. Kimberly has to pick another seat.
I mean, she can.
Well, I mean,
It's just
technically
roundabout.
she can.
It's just roundabout.
But I taught you that permutation because who wants to write 30, 29, 28, 27, 26, 25, 24, 23,
We get it.
22?
Not me.
You get it?
yeah, we get it.
You sure? 21, 20, 19, 18? Am I annoying yet?
Yeah.
Sweet.
Oh my god.
What about this last one? Consider the set ABC. How many different three-letter words are we allowed to make without repeating a letter in the word?
3P.
3P3. Or 3 times 2 times 1, because once I use a letter, I cannot reuse it.
I'm taking this clipboard home.
You are not taking my clipboard home.
Is it yours?
Yes, they are mine. Kay used it yesterday. I bought them from Staples. Thank you very much.
She bought it
Put
from
your name on
Staples. Girl, I got your name
I
You know, I'll
probably
put
should.
your name on it. She'll put her name on
on
it.
it. Alright.
Right, she's gonna put
I got everything.
Kimberly Phillips. Why can't a permutation be used for results of consecutive flips of a coin or tosses of a die?
Because you can
It's not
have the same
order.
number.
It's not same number.
Okay,
The
wouldn't
order
necessarily go
doesn't
with you.
matter.
The order.
The order doesn't matter.
But think about it. If I roll a die and it lands on a 2, can I erase that 2?
It can land on
No.
It can land on a 2 again.
Right.
You can repeat. You can repeat on a coin. You can get heads multiple times. Okay, there is no way to take off an option. So this can be repeated. All right. So we rock some permutations. As you can see, there's a couple homework problems that will be assigned tonight. Skip on over to our last little section.
Hold up. Okay.
You know Kimberly looking for the whole package.
Right.
How many pages we got.
Yeah,
She's sitting there going,
Exactly what I was doing.
all right. So, combinations versus permutations. What the heck is the difference?
I'm guessing.
Order does not matter.
Order does not matter with a combination. So in other words, if I put chocolate before I put strawberry on a cone, it doesn't matter if I put chocolate on top or strawberry on top. It's still a chocolate strawberry cone. Okay, some of you may argue with me because they do every year. But what if I want to eat the chocolate first and I put the chocolate on the bottom? Listen, doesn't matter. It's still a chocolate strawberry cone. So there is a little bit of a difference because when I do permutations, it counts chocolate strawberry or strawberry chocolate. A combination will not. So think about it this way. If this was a permutation, we're getting 2 scoops of ice cream. And I got 31 flavors. What would that look like as a permutation? 31 and 30. Okay? You don't want chocolate. You want 2 different flavors. Okay? So if you would actually multiply this, 930?
Yeah.
There's 930 different ways. Holy bejesus. Okay, but we overcounted. Okay, we overcounted because we counted chocolate and strawberry and chocolate. So the way we take care of this is we need to divide. By 2, I got that from here and here because there was 2 slots. Factorial.
Wait,
What?
Because it's 2-1.
I'm tired of learning anything.
Okay,
So,
now you lost.
hold, chill.
yeah, you did.
We're not done. 930. What's 2 factorial look like? 2 times 1. So 930 divided by 2, which is what?
465.
465. Okay.
What's the point of doing that?
The change here. How many ways can you would get 3 scoops of ice cream. So as a permutation, it would look like what?
31, 32,
31 P.
30,
Oh wait, yeah. No wait.
whoops, 29.
31 P 3.
29, which comes out to be, did I write it down?
26,907.
Divided by
3. I mean,
3 factorial. Because I've got 1, 2, 3 slots.
Okay.
4,495.
85. I got 85.
I got 95.
Hold on.
I'll put that in wrong.
I got 95.
It's 95.
Yeah, I got
Okay.
95.
I'll put it in wrong.
Okay. So again, when you divide by that 2 factorial or 3 factorial, you are taking into account that I counted chocolate, strawberry, strawberry, chocolate, that I don't want to count twice. Okay. So let's take a look at some more. Combinations. Combinations is an unordered selection of objects. Okay. N is still how many items, and R is still how many you need to put in order. Okay. If you actually use the C button on your calculator, you don't have to divide by the factorial. It will do it for you. Okay. I'm going to show you where they all are. Okay. I promise. Okay. So, again, you're going to have a section that looks like this. I'm not looking for an answer. I'm looking for what does this look like mathematically. So 6 permutate 2, if that was a P, that would look like what? 6 and 5. What am I factorializing by?
2.
2 factorial. Whatever this number is, becomes your factorial at the bottom. And a combination. So treat it like a permutation in the top, and then in the bottom, divide by how many spaces we're doing. So here, 6, 5, 4, 3, divided by
4 factorial.
4 factorial.
So we just leave it like that. We don't solve it.
Yeah, I don't want you to actually solve it. I don't want you to actually solve it. C would look like 100 divided by 1 factorial, which is just 1. D, in the top, I start at 10.
9, 8, 7, 6, 5, 4, 3, 2.
9, 8, 7, 6, 5, 4, 3, 2
over 9.
over 9 factorial.
What were they doing?
Your psychology thingy.
Observing. You're
Observing.
Oh, they're the honors class. So
Yeah.
we all won't do that. 4, 3, 2, 1 over 4 factorial
13, 12, 11, 10, 9, over 5.
and 13, 12, 11, 10, 9 over 5 factorial.
We done. We done?
We're going to do some mixed examples of permutations and combinations so you can tell the difference between the two. Goodness gracious.
We just over everything.
Let's do the next example, and then I will show you where everything's at on the calculator and give you that last little bit of time to do your homework. Okay. Just those 5 problems from the permutation side. Okay. We need to decide which one is the multiplication rule. Yes. Where things can be reused, we need to decide which one is permutations where order matters and which one of these is combinations where order does not matter. There is one of each. So again, your multiplication rule is you can reuse. That's when you do the 8 times 8 times 8 times 8. Okay? Your permutation, no repetition, order matters. And your combination, no repetition, but order does not matter.
The first one is multiplication rule
Okay? So Ashley says my first one's multiplication rule. Why?
because you can reuse them.
It doesn't say that you can't reuse. If it does not say no repetition, okay, you can reuse. So this one is 4 times 4. Okay, that one is your multiplication rule.
The second one is the combination rule.
Okay, Ashley says my second one should be combinations. What makes this one combination?
Because it's,
Because it doesn't say it's in your order.
I mean,
It doesn't say anything about being in order. It says select any group. Okay? They're not talking about order. So I've got 4 numbers to pick from. C, and I want a 2-digit number, so 4C2. Your last one then is your permutation, because your keywords here are in order. So all that does is it changes. I still have 4 numbers to pick from, but I want them in order, and I want to pick 2. Okay. All right. So in your calculators. Oh, wow. I still got matrices up here. Under the math button. Math is right below alpha. Again, if you scroll over to probability. Okay, choice number 2 is your permutation button. Choice number 3 is your combination button. And choice 4 is your factorial button.
why haven't they taught us this?
Seriously. You
So-
like to teach us the long way.
You need to know where it comes from. So, in other words, if I wanted to do 4 combination 2, like we did in part B, you would hit 4, then you would go to math. You would need to pick your combination button. So choice 3, and you would put in a 2, and you would hit enter. So your answer to part B would be 6. That we just did, those 4C2 and your 4P2.
That would be how many ways we can do it.
Okay. Same thing. 4, if I want to do the permutation, I would go to probability. I want my permutation. 2. Well, that's 12.
What?
Remember, permutation order matters. So 12, 1, 2 is different than 2, 1. In a combination, 1, 2 is the same as 2, 1. Think about it. 12 is the number you would get permutation. What would you divide by? What factorial?
2.
2 factorial, which is what?
6.
2 factorial is 2. 12 divided by 2 is 6.
So that's another way.
Okay. So that's where all of those buttons are. You have some time left. I want you to work on those 5 problems in your notes on permutations. Yes, sir. Yes.
Do your homework, basically.
Yes, do your homework.
Do 1 to 5?
Yes.